Good morning, dear students. Today we will start fifth unit, that is antennas. So, what is meant by antenna? What you know about antenna? Basically, without antenna, there is no wireless communication. Means, in order to establish a wireless communication between two systems or between 2 points, we need an antenna. Without an antenna, there is no wireless communication. Means, in order to establish the wireless communication between 2 points, we need antenna. We need antenna. What is the definition of the antenna? Antenna is a passive element. It is a passive element. It is a passive element, and it may be wire or rod. It is a wire or rod, which is used to radiate. Which is used to radiate electromagnetic waves into the space. Which is used to radiate the electromagnetic waves into the space. So that means antenna gives what? Electromagnetic radiation. Electromagnetic radiation means antenna sends the signals in the form of the EM wave radiation. EM wave radiation. Coming to the types of the antennas, there are different types of the antennas: wire antennas, reflector antennas, aperture antennas, lens antennas, microstrip antennas. We can find this type of antenna, that is a reflector antenna, in our home. That is a Tata Sky dish. The dish is nothing but what? A reflector antenna. This reflector antenna is also found in Ega movie, Rajamouli. So when power gone, Hero Nani plays Hero Nani thinks, Hero Nani gives some writing to the heroine when she is drawing. Okay, in the middle of the drawing, there is a power cut. Because of that power cut, to impress heroine, Nani uses this reflector and provides lighting to the heroine. Okay. Of course, in our homes also we have this reflector in the form of DTH, Tata Sky dish. In Doordarshan also, we have these type of large reflectors, wire antennas in our cars, microstrip antennas. These are very popular. These are used in our mobile phones, microstrip antennas. Okay. Now coming to the performance of the antenna. This performance of antenna is measured in terms of its parameters. Performance of antenna is measured in terms of its parameters. What are the parameters of the antenna? What are the parameters of the antenna? First one, as it gives the radiation, the first parameter is nothing but radiation pattern. First parameter is radiation pattern. Radiation pattern. And second one is this radiation pattern can be represented in terms of this radiation intensity, or else radiation intensity represented by pi r u. It is represented by capital pi r u. And next one is gain of the antenna. Gain of the antenna. Gain. Next one is directivity. Directivity of the antenna. Directivity of the antenna. And fifth one is beam width of the antenna. Beam width of the antenna. Next parameter is beam area of the antenna. Beam area of the antenna. And another parameter is the beam efficiency of the antenna. Beam efficiency of the antenna. And eighth one is radiation efficiency of the antenna. radiation efficiency or else antenna efficiency. Efficiency of the antenna. Effective aperture or else effective area. Another parameter is effective aperture. Effective aperture. And 10th one is effective height of the antenna. Effective height of the antenna. Effective height of antenna. Effective height of antenna. These are the some parameters of the antenna. First, we will discuss about the radiation pattern of the antenna. Radiation pattern of the antenna. The radiation from the antenna is graphically represented by using this radiation pattern. Actually, it is not parameter. It is graphical representation of the radiation from the antenna. So, radiation pattern. Radiation pattern. Radiation pattern. I told that antenna gives the radiation. The radiation can be represented by using this radiation pattern. Radiation pattern is nothing but what? Graphical representation of the radiation from the antenna. Graphical representation. Graphical representation of the radiation from the antenna. Graphical representation of radiation from the antenna in different directions at equal distances. In different directions, let us say in different directions means what? 360 in 360 degrees. So let us say antenna is radiating. Let us say antenna is placed here. So this dot, okay, at the center, it is radiating in 360 degrees. Let us say here antenna is radiating maximum in this direction and minimum in this direction. Here in this direction somewhat, in this direction somewhat. Okay, then maximum in this direction is represented by major lobe. Maximum in this direction is represented by major lobe, and here in this direction it is radiating small. So that is represented by like this, like this, like this, like this. These are known as what? Lobes of the radiation pattern of the antenna. Radiation pattern is nothing but what? Graphical representation of the radiation from the antenna. Graphical representation of the radiation from antenna in different directions at equal distances. So that is represented like this. Suppose in this direction I have the maximum radiation, that is represented by major lobe. So this one is nothing but what? Major lobe. Major lobe means what? A lobe which contains maximum radiation in the desired direction. Next, these are the lobes known as what? Minor lobes. In this direction radiation is less. So these are this one, and these two are nothing but what? Minor lobes. Minor lobes. Minor lobes. And this one is also in this direction also some little bit radiation. So this one. So this is known as back lobe. Back lobe. This one is known as what? Side lobe. This one is what? Side lobe. Side lobe or back lobes are nothing but what? Minor lobes only. Minor lobes means what? A lobe other than major lobe is nothing but what? Minor lobe. Side lobe means what? A lobe which is adjacent to the major lobe is known as what? Side lobe. What is meant by back lobe? A lobe which is exactly opposite to the major lobe. Exactly opposite to the major lobe. Or phase difference between back lobe and major lobe is nothing but what? 180 degrees. So this is nothing but what? A radiation pattern of the antenna. Radiation pattern is nothing but what? Graphical representation of the radiation from the antenna in different directions at equal distances. As antenna is the directional element. What is meant by directional element? The directional element means what? It radiates maximum in particular direction only. That maximum is represented by this major lobe. That maximum is represented by major lobe. And in this direction we have maximum radiation, that is represented by major lobe. In other directions we have the radiation that are represented by minor lobes. What are the minor lobes? Side lobe, back lobe. Side lobe means what? A lobe which is adjacent to the which is adjacent to major lobe is known as what? Side lobe. Back lobe means what? A lobe which is exactly back to the major lobe, or else exactly having a phase difference of 180 degrees. That is known as what? Back lobe. So this is about the radiation pattern of the antenna. Next, another parameter is what? Radiation intensity. Listen carefully. Radiation intensity. Radiation intensity. Radiation intensity. Represented by pi or u. I am here taking u. It is defined as radiated power per unit solid angle. It is defined as radiated power per unit solid angle. Per unit solid angle. The unit solid angle is defined as what? Represented by this omega. Radiated power represented by W or omega. So radiated power per unit solid angle represented by what? Radiation intensity U. As the solid angle changes, radiated power through that solid angle also changes. So therefore, this dWr is equal to what? U into d omega. Apply integration on both sides to get the total radiated power to the solid angle. That is UR is equal to U into d omega. Where d omega is equal to sin theta, d theta, d pi. Where theta is vertical angle, it is from 0 to pi, and pi is a complete angle, that is from 0 to 2 pi. Now we will see how we got this d omega is equal to sin theta, d theta, d pi. For that, we need to define the solid angle definition or steradian definition. Steradian definition. Steradian. Steradian. Steradian is a solid angle. It is a solid angle with its vertex, at the center of the sphere, at the center of the sphere, of radius r, radius of the sphere is r, subtended by an angle, subtended by not angle, okay, subtended by an area whose area is equal to r square, whose area equal to r square. So means here I am taking the sphere. Let us assume this as the sphere with its vertex. Okay, having a radius r. Coming to the definition, it is a solid angle. It is a solid angle. I am taking that angle here. Okay, with its vertex at the center of the sphere. At this one is the vertex. Okay, here we have the angle. That is nothing but what? Solid angle. It is subtended by an area whose area is equal to, here we have the area. This area is equal to what? R square. Means here angle is defined, this solid angle is defined, that is omega is equal to what? It is defined with respect to r square, that is r square. And as it is area, we have to take surface area is. As this area changes, there is no change in this area. As this one changes, that leads to what? A change in this d. That change leads to change in omega, that is represented by d omega, difference in the omega. Therefore, d omega equal to what now? In spherical coordinate system, already we have what? ds. ds is equal to what? R square sin theta, d theta, d pi. Now we have r square gets cancelled. Finally, what we have? D omega is equal to sin theta, d theta, d pi. That is d omega equal to sin theta, d theta, d pi. From this, we can define U average, average radiation intensity. Okay, average radiation intensity. Already we have what? Radiation intensity. It is defined as what? Radiation intensity, radiated power per unit solid angle. That is WR is equal to U equal to what? dWr by d omega. Okay, from this we have what? WR is equal to what? Integral WR equal to U d omega. Let us take an antenna which radiates energy uniformly in all directions. That type of antenna is known as what? The type of, in this direction, let us say 2 watts. In this direction also 2 watts. In this direction also it radiates 2 watts power. And in this direction also it radiates 2 watts. In this direction also it radiates 2 watts power. This type of antenna is known as what? Isotropic antenna. Isotropic antenna. Isotropic antenna. In that case, radiation intensity is what? It is uniform in all directions. It is uniform in all directions. As it is uniform, we can take that is what average of this one gives what? 2 watts only. So that gives U average integral d omega. That equal to what? U average. We need to find this U average in terms of radiated power. That is integral d omega. D omega means what? Sin theta, d theta, d phi. Now let us simplify this one. U average. Theta terms sin theta, d theta, 0 to pi. And here integral d pi. So 0 to 2 pi. After simplification, you will get this one as what? U average. U average. Integral sin theta d theta, that gives minus cos theta. By substituting the limits here, you will get this one as what? Pi. Okay. So that is pi minus pi. Pi minus of minus pi, that gives what? 2 pi. And here also it gives what? 2 pi. Actually here it gives not 2 pi. It is what? Cos pi value is minus 1. Integral sin theta is what? Minus cos theta. Of course here it gives what? Minus of minus 1 minus 1. That gives minus of minus 2. That gives 2. So that's why finally you have what? That is U average into 4 pi. So therefore U average is equal to we can write WR is equal to what? U average into 4 pi. That equal to what? U average WR by 4 pi. This is the relationship between average radiation intensity and radiated power. Now we have discussed the radiation pattern, radiation intensity. We need to discuss about this one, that is gain. Gain is defined as, actually we have two types of gain: power gain, directive gain. Power gain means what? Loss considered. Here, loss not considered. Not considered loss power. Not considered loss power. That is WL. Only here we consider what? Radiated power. Okay. Here, sorry. Here we consider only radiated power only. Here we consider total power. That is what? WR plus WL in the definition. Okay. First, gain. Gain is defined like this. That is, gain is equal to, it is defined as ratio of, ratio means we have numerator and denominator. Radiation intensity from the practical antenna to the radiation intensity from the ideal antenna or reference antenna. Isotropic antenna is taken as what? Isotropic antenna is taken as what? Isotropic antenna is taken as a reference antenna. For isotropic antenna, U average is equal to what? WR by 4 pi. Because as it radiates the energy uniformly in all directions, we have average radiation intensity only. That average radiation intensity given by what? U average is equal to WR by 4 pi. So therefore, gain is equal to, gain is equal to radiation intensity, that is pi, or U. Okay. And I am taking, instead of taking pi, I am taking U only to avoid the confusion. So radiation intensity from the test antenna to the radiation intensity from the isotropic antenna. For isotropic antenna, radiation intensity is taken as what? U average. So we know about this one, that is U, and U average, that is what U average value. Our expression for U average is WR by 4 pi. So therefore, here we have what? U by 4 pi into U, 4 pi into U, W R. This one is what actually, this gain is known as what? GD, that is directive gain. Total power is not considered. Suppose if I take total power, total radiated power, then GP, I have to take what? Instead of taking only radiated power, I have to take what? Total power, that is WT. Where WT is what? WR plus WL, radiated power plus lost power. Where radiated power can be written as what? WR is equal to I square RMS into RR, that is radiation resistance for the radiated power. For the lost power, we have loss resistance, that is IRMS square into RL. So from this, we have what? GP. For the GP, we have to take what? Lost power into the account. And whereas in GD, in the definition of GD, lost power is neglected. That means lost power is taken as what? WL equal to 0. Then we have what? Another parameter, that is radiation efficiency. Radiation efficiency. Somewhat it is related to GP and GD. Radiation efficiency, antenna efficiency defined by ratio of the radiated power to the ratio of the total power. Radiated power considered in the GD and the total power is considered in the definition of GP. WR is equal to what? IRMS square into RR. WT is what? IRMS square means actually it is WR plus WL. So therefore, we can write this as what? IRMS square into RR divided by IRMS square into RR plus RL. So this one cancel. Finally, antenna efficiency in terms of the radiation resistance like this, RR plus R. Suppose if RL equal to 0, in that case, antenna efficiency factor equal to 1. And relationship between GP and GD. Or else neta in terms of GP and GD. Okay, we have neta. Okay, let us take GP by GD. GP by GD. What is GP? GP is what? 4 pi into U by WT. And GD is what? GD is what? 4 pi into U by WR. So this one cancel. WR by WT. Just now we have WR by WT. See, that is what? RR by RR plus RM, which is equivalent to what? Antenna efficiency neta. So therefore, neta can be written in terms of the gain parameters GP and GD. If GP equal to GD, that means there is no loss. Then you have what? 100% efficiency. So these are the some parameters of the antenna. What parameters we have discussed in the antennas? So first we started our lecture with the definition of the antenna. Basically, antenna definition is what? It is a passive element which is nothing but wire or rod, which is used to radiate electromagnetic waves into the space. Types of antennas: we have wire antennas, reflector antennas, aperture antennas, lens antennas, microchip antennas. We can find our reflector antennas in our homes in the form of DTH, Tata Sky. Microchip antennas are widely used in the mobile phones. In our mobile phones, we have antennas that are nothing but microchip antennas. The antenna performance is measured in terms of its parameters. What are the parameters? Radiation pattern, radiation intensity, gain. Radiation pattern is nothing but what? Graphical representation of the radiation from the antenna in different directions that is established. Radiation pattern, in the radiation pattern we have lobes, major lobe, minor lobe. Major lobe is nothing but what? Which is used to indicate the direction of maximum radiation. Except major lobe, all the lobes are minor lobes. We have side lobe, back lobe. Radiation intensity, radiated power per unit solid angle. Radiated power per unit solid angle. This one. So then relation is what? WR equal to integral U d omega. For isotropic antenna, of course here we derive d omega equal to sin theta d theta d phi, the definition of this stereo. And we have relationship between U and WR. Final relation is nothing but what? U average equal to WR by 4 pi. In this relation, we define gain. Gain equal to what? It is defined as what? Radiation intensity in particular direction. Radiation intensity defined by U. And radiation intensity from the isotropic antenna. For isotropic antenna, it is U average. We defined GD and GD. GD means what? Neglecting loss power means WL equal to 0. Only we consider WR. GP means what? We have to consider the total power. That is, total power is sum of radiated power and loss power. We got GP is like this. And we defined the antenna efficiency. That is nothing but what? It is defined as the ratio of the radiated power from the antenna to the total power given to the antenna. That is, WR is IRMS scale RR, WT is what? WR plus WL. Then we have like this, that is neta equal to RR by RR plus RL. Then we can write or we can derive the relationship between neta and GP, GD. We know GP, this one, and the GD, that 1 by GD can be written like this. Finally, we got WR by WT. This WR by WT is nothing but what? RR by RR plus RL, which is equal to what? Antenna efficiency. Therefore, antenna efficiency is equal to what? GP by GP. Okay, this is about today's class. We will meet in